Hey everybody, I'm Kit Merker. I'm one of the organizers for the Seattle SRE Meetup, and it's great to be with you all remotely, online. You know, we had a great one in January. It feels like a long time ago at the Google office, and here we are via Zoom, graciously hosted by our friends at Getty Images. I want to introduce you to Jolene Kidney.
Well, welcome to Getty Images virtually. We had planned back in March to host this at our Seattle office in downtown, but unfortunately, as you all know, our best laid plans have been subverted. So we are hosting this via Zoom today. So we're glad to see all of you virtually, and we look forward to hopefully in the future being able to see you in person. Just wanted to take a moment to tell you, we're excited as Getty. We're celebrating 25 years. If you haven't heard of Getty Images, we've been around for some time. If you have heard of us, it's likely because you've seen the little Getty Images tagline at the bottom of maybe a photo attached to a news article. So we're excited that we've hit that milestone, and we're looking forward to what we might be able to do in the next 25 years. Today, just wanted to talk a little bit about our journey for SRE. So first off, in 2018, one of our app directors, Andrew Smith, gave our CTO the ever famous SRE book. He drank the Kool-Aid and he became a believer and decided that this was something that we should do. After we had finished our big migration to AWS, it was time for us to pick this up in the beginning of 2019. So in the first quarter, a team of engineers was formed to investigate options. We finally came up with what we thought was the best solution, which you guys maybe have heard of, Prometheus and Grafana, and began to establish that metrics platform. In the second quarter of 2019, we chose our first department, which is 1/3 of our customer-facing website, to be our guinea pig. To say, we have a new metrics platform, we have this new SRE thing that we want to do, would you come along for this journey? Instrumenting their systems and began to figure out what SLIs and SLOs and all of those things that we call part of our, what we do at Getty as SRE. In the third quarter of last year, our first SLOs were established for that department. And we started sending these daily email reports. They reported whether or not you were hitting your SLOs really for a 24-hour period of time. They were going to the leadership. So they were going to our service owners, our application owners, and our CTO and VPs. And so they all began to start seeing on a daily basis what was going on with SRE and how we were approaching it, and whether we were actually achieving our objectives to be more performant and reliable. We also started showing this via Grafana, so you could see all of the SLOs, and you could watch these metrics go up and down for periods of time. So we instituted that visualization as well. In Q4, our internal platform was developed that we lovingly called Portugal, as a nod to Brian Brazil, to ease the onboarding of developmental teams. They didn't have to write their own PromQL, so they could just select from lists to add recording rules for their systems. In addition, we started with our second guinea pig, which was the other 2/3 of our customer-facing website. So they began work in earnest to instrument their systems and to start establishing their SLOs. So 2020, we began by automating our SLO documents. So if you've read the SRE book, you know that these are important for the ratification and understanding of how those SLOs were implemented and ratified, and how we make sure that we're targeting those and keeping in line with those all the time, but not having people have to ask the questions, wait, why did we choose that SLO? Does it include that thing? So we took Portugal and we plumbed all that through as well. So you magically get one of those SLO documents as you're onboarding as a system. We also began investigation into switching from request-based to time-based, and we're still under a transition there as well. If you'd like to know more about that, or you'd like to share some information about that, we would be very open to it, as it has been quite a debate from our CTO on down. In addition to that, we had our first dedicated effort to remediate SLO misses within our customer-facing website. So we started taking these performance lapses very seriously and decided that this was impacting our customer experience and that we really wanted to make sure that we were making those changes and putting effort towards doing that. So this was SRE, what we had always hoped and dreamed, coming into practice, where our leadership on down was supporting a significant amount of effort and pivoting to our efforts of our engineers to remediating those issues. So how about now? Where are we now? So right now, the beginning part of Q2, we have started to implement our alerting system that alerts on SLO misses. So this is the automation of that process. So instead of just a daily report, we were actually looking at burn rates, slow burn, fast burn, and deciding what kind of notification methods we want to do that. We've plumbed that all from Prometheus through PagerDuty. And we're just beginning to kick that off this week, going live. In addition, we're wrapping up that second CFW app. And so what's coming up next in this quarter? We are looking at onboarding what we consider the last third of our customer-facing website and establishing SLOs for that. And in addition to that work, at the same time, we're looking at switching over to request-based SLOs. Further down the road, we're looking at long-term reporting and higher level SLO dashboards that can be looked at the leadership level. That's a really, really quick tour through our journey. And of course, we'd love to share more. And again, we look forward to someday being able to see you in person.
Thank you, Jolene. Next up, we'd like to introduce Rob Jahn. Yes, I got it right this time. And with no further ado, we're going to let him introduce himself and take it away. Very excited to see this talk.
Right. Well, thank you so much. Yeah, I think that's, what you just described is what we're seeing a lot with our customers, kind of going through a journey. And so what my talk today, I'm going to go ahead and share my screen, and I have a couple slides, and I'll kind of tell you what I'm going to do. Just get this going here. So yeah, so what we're seeing is this embracing of service level objectives and indicators to really kind of drive prevention of code not reaching production that's bad from a kind of non-functional sense. So there is actually a talk later where we're talking deeping about the security aspects of things, but what I'm going to be talking about is kind of what's motivating this drive towards automating the service level validations, what we call quality gates. And I'm going to be presenting a framework that at Dynatrace, where I work, we've developed an open source platform called Captain. And one of the aspects of that is kind of services that can actually automate that. And that's what I'm going to be demoing today. So in my case, I'm going to be using Atlassian with a kind of a live demo, but Captain is with the REST API, can integrate with a number of things. And I'm going to walk through that and how it works and how the service level objective kind of, spec that we've defined. And then, how you give you some more information too. So that's kind of my agenda today. And really what, it's driving this. So as we're moving into, three-tiered applications, monolithic applications into microservices, this sort of realization of breaking things down to component levels, which I think we've talked about. My background, by the way, I was a consultant for 20 years doing a lot of performance engineering and architecture. And a lot of traditional apps, as they're monolithic, as they're waterfall, you're doing this big bang testing. So we're at the age now where as people are embracing Kubernetes, microservices, this is now a reality. So but what this means though, is we're now having many more tests that need to be run, and we just can't do things in a manual way. So what we're trying to do here is do the things that a person is typically doing, but kind of but do that in an automated way. So we're not going to fully automate all quality. It's more around, almost like a Six Sigma, keeping within the guardrails of your service level objectives. And if there's a problem, then we can notify the right people to investigate it further. This is coincidence, but we actually were inspired a lot by the site reliability engineering book It's actually free. You can also get that online, but the key things, and these are some definitions if you're not familiar with SLI and SLOs, this is right from the book. And this is really what it's important to understand, that this terminology, we just throw them around. So there's really an indicator is the data that you're collecting, whether that's a response time or a resource usage, error rates, things of that nature, and then the objective. So this is what you're actually measuring it for. So it's typically done within bounds, like a lower bound, upper bound. So within your bounds, you're going to be, that's kind of what we're measuring for. Because again, it's all about continuous testing and kind of staying within these things, build to build. So, and so how the concept we have to automate this is we want to put these SLO and SLIs into spec files, read that, retrieve the data from some source, calculate a score that says you're compliant, and then let you indicate this is a pass fail kind of status. And this is something that could be then introduced into a code pipeline where this is completely automated. And that's kind of what I'm going to demonstrate today. So just some examples, some other inspiration, because again, we work with at Dynatrace quite a few customers. So Mark Thomason was a guy that worked at PayPal, which was one of our customers, and he implemented this concept of, again, by introducing it into your pipeline and then hooking it in with a Jira ticket, they were able to drive this into a completely automated self-service model, which we call performance as a self-service is what we've been calling it. But the ticket can come in, go into a platform, provision your test, queue up the test, attach the feedback right on the ticket. And this is getting the feedback to the developer, because that's what developers want. They don't want to wait, to the next sprint to there's an integrated test and get that feedback 3 weeks after the fact. It's really, the idea is like rapid feedback. Within Dynatrace, we had this concept too, because we have a monitoring tool, Dynatrace platform, collects tons of time series metrics. So internally, as we were testing our own software, we had internally from our DevOps team, they were actually defined this early performance spec and were doing things internally. And they built these dashboards to compare build to build to build every single time they were doing something. So that became kind of inspiration for us. So multiple metrics. So it's key that it's not just one metric, it's multiple metrics. Different stages of your life cycle may have different metrics, different types of app. It's a front-end app, middleware component or service. Different metrics are gonna apply to the different component. So then just as a segue, I'm going to go kind of rapid because I want to do more demos, but just as a quick introduction to Captain, this is the open source project I mentioned earlier on the call, where it's more than just this one service for evaluating things. This is the concept of is having a declarative sort of abstraction of what you want to deliver software for, whether it's blue-green deployments, canary deployments, and then have these automated kind of validation rules. And then everything is orchestrated instead of really just a pipeline that's scripted. Things are more orchestrated through events. So underpinning the Captain platform is a message bus where all these events from various services are being orchestrated by the platform. And then the idea too is that different tools, if I'm using JMeter and then I go to a commercial testing tool, or I want to swap in different data, that these services are subscribing to these events, and it's a real easy way to swap in and out different tools and then kind of do it in a standardized way within an organization. And then Captain itself is deployed in a Kubernetes platform, so then it's scalable for more services to consume. So as we've rolled this out, this has been a project that's been about a year formally. So and then as we've kind of gotten some early adopters and people, the quality gates and performance as self-service were kind of our top kind of survey feedback of the use cases that people felt were the ones they could start with right away. And so let me just walk through the use cases, then I'll jump right into kind of the demo. So the automated SLO, this will look similar to the picture I just showed. And so the idea is you have your developer, you have the Captain platform, and then you have various data sources. So it could be Dynatrace, it could be Prometheus, it could be testing tools. And the idea is that the SLO is not tied to a particular tool. It's more of a spec, and then you have different data sources. So the idea is I can start an evaluation by sending sort of an event into Captain. Captain will call the service, which is what we call the Lighthouse is the name of the service, the Lighthouse service. It's going to go then parse that file, pull in the data from these data sources, perform the evaluation, and send it back to the developer. So this could be, this event could be triggered, and which is what I'm going to show, from a pipeline. And then the other use case is really more of a full-blown performance test cycle. Again, imagine I have Captain, I have my environment over here, and now after a deployment is complete, or I can trigger it to say a deployment just happened, I can then ask Captain to go ahead and run my tests. So again, the cloud event would come in, the services are listening for an event, they fire off their load test. When the load test is complete, that sends another event out. The event will say, now go ahead and perform the evaluation, do the same score, and send it back. So this sort of becomes what I want to show you guys. All right, so let's start with the first one, which is automating kind of just the evaluation in a pipeline. So in my environment that I'm going to show you is I have an application under test. In my case, it's a really simple node application. I have Dynatrace as my primary source of data to collect metrics from the test. I have installed Captain, which I'll show. And then also Captain, again, we can hook up in different services that listen for notifications and then publish those out to different tools. So in my case, I have Teams and Slack both set up. So here we're going to have developers going to check in our code and files. In my case, this example is Bitbucket, but it could be Azure DevOps, it could be Jenkins, it could be really anything. So a typical pipeline is performing these steps like building your artifact, deploying your code. Then here we're going to run our tests. This is just a detail around Dynatrace where we can inform Dynatrace that these things are taking place. And that kind of also informs and give context within the Dynatrace tool, which we're not going to get into today. But then the idea is here we can perform our service level check, and then we can decide if our pipeline passes or fails. And then along the way, we're sending notifications. So I'm just going to jump now over to my demo setup. And so just as an aside, so this is all this code is available as an aside, and I'll have all the links for you guys. But what I have in my case is, sorry, this little window out of the way. So in my case, I have an application that's out there. It's a simple node application, and this is running now in my environment. And what we'll see in this case is the app, just for demo purposes, built into the app. If I tell it what version it is, built into the code are different problem patterns, and that's what we're going to simulate. So if in my case, I have two environments. I have a staging environment and a production environment. And what this is doing is just a simple refreshing the page so you see the front end UI for both the demo staging and the demo production. So there actually is a Kubernetes cluster behind the scenes. Both of these are running as two different pods and two different namespaces. And this is the UI just being rendered here with the flashback. So if I'm going to go ahead and run my code, so I'll simulate the change. So here I am locally. I'm going to say, I'm going to just change my version, which is one of the files in my code repo. And I'm going to go ahead and commit this change. I'm going to say, let's update to version 2. This has now pushed my change. So just imagine I was a developer, made some changes. Now I'm version 2. And let me come back to my pipeline. And so what should happen here, if I go to pipelines, this job will now be running. So it's in progress. So again, just like Jenkins or other tools, there's a trigger that as soon as the commit took place, my pipeline starts to execute. So what this is going to do is just similar to that diagram. It's going to go through a series of steps of deploying my application, running my load test, calling the quality gate, and then making a decision whether it's going to promote it into the quote unquote production environment. This is going to take a couple minutes just to run. So what we'll see once this is done is that this live will change to version 2. The quality gate will be run and evaluate the results and say, sorry, I'm not going to make version 2 get into the production environment. So while that's running, and I'll come back to that, so let me just go and explain a little bit more about what the SLI is doing. So the concept is, as I just mentioned, we have different indicators, and it could be response time, failure rates, could be within the backend. So this is something that a tool like a Dynatrace can give you. Is not just the front end calls, but Dynatrace can look in the running code and do things like, what are there exceptions within the running app? What are the database calls, connections, etc. And so I have my service level objectives for each of these indicators. And again, remember, it's like a range. So I have a passing target and a warning target within these different ranges. And then then each of these kind of add up to be an overall score. So it's really it could be these that can be weighted, they can be just informational, but the idea is you have an overall score. And then as I run my build, I capture the actual metrics and compare it against my service level. And in this case, everything is in line, so I get a perfect 100% score. Here, let's pretend I have another build, And here, you know, these are more like warning statuses because they're still in line, but they're not great, but you pass. And here's another one where this is failing altogether because again, my target, I needed to have a 75% pass. In this case, this added up to be 62, so I fail my pipeline. And then here, maybe I do another build and everything's good and I'm good again. So that's kind of conceptually the service levels. So now let me show you how Captain implemented this. So as I mentioned, there's a service that Captain has that can get data from different backend sources. And so what we have is a declarative service level indicator file that this definition of the query will map to the tool. So this sort of syntax is the syntax for Dynatrace to pull out kind of time series data. But if your backend was Prometheus, you could have Prometheus things. If you had a different tool, you know, we could have Aquasec. You know, if the Aquasec has an API, Aquasec can get metrics around, you know, kind of security related things. So it could be, you know, any sort of non-functional kind of aspects. Then your service level definition, again, in a YAML structure, allows me to say, in my case, I want to measure these service level indicators and then have a criteria, whether it's a fixed threshold, like it has to be under 100 milliseconds, or I can be plus or minus, because what built into the service is the ability to kind of look back across previous builds and get, say, like the average of a particular indicator and say, you know, as long as I'm plus or minus 10% of that thing, I'm still good. And so this is just some animation. So I'm going to skip this real quick, but that's the idea, is that you gather the data and you can get it, and the pick diagram is here, like you can get data from multiple sources that all add up to an overall score. And that's kind of where it makes it really flexible. So then a more detailed example is just to kind of walk you through what it is. So in the spec file itself, and this spec, by the way, is on the, so all of this is on on GitHub. There's an organization called Captain. I'll have the links at the end, but it's github.com Captain, and then there's a spec definition where this is all documented and we want feedback. But the strategy in this case could be a single result comparison, or it could be across multiple builds, and you can define how many builds you want to do, and then you can define how you want the metrics to be aggregated. So imagine I have an objective like response time. Here's time series data. So I've kind of defined it. I want to be within this range. And then you also have the ability to kind of, the way things get weighted is if I get a passing grade, I get like a 1 point. If I get within the range, I have a half, 50% of the score. And if I fail it, then I get 0%. And so if I had an actual measurement, say a 400 milliseconds, I'd get kind of like half points for that. And there, if I had another SLI, say SQL statements, same thing. I can have kind of ranges. I can get an actual score. In this case, this guy passes. My overall score is something like this. And in this case, I had an 83, because I weighted this. I'm sorry, I missed this little detail. But see, you can actually add weighting. So in this case, he passed, but he counts as 2 points. This guy got a half point. So he got 2.5 out of 3, 83%. So that's kind of the details of the spec file. Let's go see if the pipeline's done. Okay, so I just went back to my screen. You can see now version 2 got deployed into my environment. Let's go back and look at the pipeline. So you can see it chugged along. I might have to refresh this just to check. And okay, what it's doing now is it ran the load test. And again, my load test, as an aside, was just sending a bunch of curl requests to hit the front end. So my load test wasn't too exciting. But now what it's doing is calling the quality gate. And so here we go. So actually, as we did it got the results back. And I'll show you what this, so this is a lot of raw JSON data because each metric I have in my spec file gets evaluated and scored. And so, but to see it a little easier, I'm going to show you what we call is the Captain bridge. So part of Captain, there is a web UI where you can see the events that are taking place within, within your Captain environment. So in my case, I'm working within my staging environment for my simple app. And so what took place, Captain got initialized with the ask of running a quality gate. So it received an event called start evaluation. And I can look in the details. So the evaluation was, details around, what was the service, what was the stage, what was the start time and end time. And then it would go look to see what was registered for the service level objectives for this service. And then as it pulled the data, it performed the actual evaluation. And what we can see is each of the metrics that I had defined in my spec file, I can see the actual metrics. So in my case, the error rate was outside of my range. And I could also, just some features, I can see the same data in graphs, and each of these bars represents different builds that it took place in my environment. So I can kind of interact and quickly evaluate things. I can look at, the scores, for say response time, again, over, maybe not that one, this one, sorry. So again, I can kind of see it graphically. So this is kind of where the data is stored from each result in a Mongo database within Captain. And then this UI is able to pull that back and visualize the data itself. So what I'm going to do is just kick off another pipeline. So if you notice if you remember in the app, build number 1 was normal, build number 2, 50% of these API calls will fail, which is why we saw that higher error rate. But I'm going to go ahead and just flip this back to normal so we can see the pipeline pass this time. So let's go ahead and just change this to version 4. And then again, this will take a couple minutes. So I'm going to move on to the next example. So this is going ahead and running. If I go back to my pipeline and refresh it, you'll see that, it's now kicking off the pipeline again with the version 4. So this will take a couple minutes. So let me just walk on to the next use case. And so this is what we call performance as a service. I kind of described this before, but the idea, and this is what we're seeing, is we're also seeing, companies moving from these, shared centers of excellence, offshore teams, especially in the larger enterprises, to really pushing this back into the engineering team to be responsible for running their own tests. And I think, that was mentioned earlier as they've gone through their journey. It was like a menu of SLOs that the developers can do. So we're actually seeing shifts of the performance engineering teams being more helpers as opposed to a bottleneck or everything has to go through kind of team, where they help developers establish their SLOs. They help them analyze the production results to establish what makes sense. They set up the standards. They help set up the platform. They give them these menus. They help them educate them on what SLOs are. They help enable the engineers, because there's way more engineers than there is performance testers. So we need to shift this back on engineers. But engineers want to write code, so they just want to run the test in an easy way. They want to enable these testing teams to service the engineers so they can scale higher, and then pushing tools back to the developers, so they can have it themselves, and then scale through automation. So this is kind of what we're seeing companies do. And then, so this example, I showed you an example from PayPal. This is something I set up to kind of simulate something similar. So imagine you have Jira, and I have a story, and I want to kind of just invoke this performance process through Captain right from my Jira ticket. So in my case, I'm going to send another event to say, go ahead and run my test against my service, assuming it's already deployed. Maybe some other tool deployed it. But I'm going to go through these series of services. So again, these are all swappable. So if you have different tools, that's the beauty of Captain. So the JMeter service is going to run my test. The SLO, which you've already seen, is going to evaluate the targets. We're also pushing context through the Dynatrace service back to another tool. And then the notification service is sending out notifications. And then we also wrote a Jira service for Captain, me and a developer from Australia. So I was up kind of late last night trying to get this all finished. But the Jira service will then publish these results, listening for Captain events back into my Jira ticket. So let me just show you that next, because my pipeline is still running, so it'll take a couple more minutes. But let's switch over to Jira. Actually, here's Jira. Sorry, give me the right tab. So let me just move this over. So imagine this is my I just set up a Kanban board to make it easier. So I just have a project, I have a story. And what I've done in this story is I've kind of built in some custom fields so that, the person making the ticket can fill in the Captain project, service, staging, and that's how it's registered with Captain, so it knows how to find it. And then I want to run this particular performance test. Yeah, that's it. So built into Jira, if you're not aware of this, there's something called Jira for Jira automation. And so you can build, and I'll just show you this rule real quick. And you can trigger this through a policy, like an event change, or you can manually trigger it. So in my case, I have performance as a service manually triggered. And then all it's going to do is send a webhook with the payload to Captain. And if you can see all these little brackets, this is something called smart fields in Jira, where you can define these definitions. So what's happening is when it's on the Jira ticket with this label, it can pull the thing off the ticket and send it. Same thing with this. This is like a built-in value for the Jira ticket. So let me go ahead and go back to the project and run it, and then you'll see what it does. Just for the sake of time, I have another. So instead of showing the performance test one, which takes like 5 minutes, I'm going to show another, the second rule I have built in, which is just the quality gate. So if I run just the quality gate, it doesn't need to run the test. So let me go ahead and run that. And so you can see this is all out of the box Jira. I didn't do anything other than define my rules. So now it's invoking it, calling my webhook. It should be finished momentarily. There it is. Okay. And then if I see, it actually was instantaneous. So it automatically got my result, and you can see what our service did is it built a new Jira issue with the results coming back from Captain. So we used the API of Jira to then populate the card with the description. We can have the link now, either one of these, back to the Captain bridge, which is what I showed you, because Captain has deep links to basically the job at the steps. As soon as this renders, you can see it jumped right to that specific evaluation that I just did. So if you notice here, we've added labels. That's a feature that you can pass in any labels you want. It'll show up here. So this was my Jira ticket number 10. It came from Jira automation. And then again, what you saw earlier, it's doing the evaluation of these metrics. So that's kind of the power of that. So let me just jump back. I got a couple more minutes here, within the amount of time. But if I go to my pipeline, let's just see if this is done. Because again, remember back on the pipeline, this is deploying version 4. So it's finished running the load test. It's right in the middle of calling the quality gate, excuse me. And once this is done, it should pass because this is a good build. And then it will deploy the app version 4 so it'll get past this step now if it finishes. So you can, so what's Captain is, it's an asynchronous call. So there's a 2-step process. I call the Captain to say, start this evaluation. And then I basically keep the polling for, is it done yet? Is it done yet? Is it done yet? And then, it will be done probably as we're watching it here. And then what will happen is, if I go back to the sample app, version 4 should deploy into production. So that would be the demo I want to show you guys. So let's see if it finishes. Well, if not, let me do this. Let me go back quickly to just my slide because I think I'm out of time. So where you can learn more, I guess, about this is we have a website, captain.sh. And there's a whole website that explains what Captain is. And again, one of the use cases is this thing I showed you today. There's also tutorials, which is, if you go to captain.sh, this is one of the menu options to navigate to this thing. And then there's a bunch of tutorials of how you can actually try it. And then we encourage people to help, build more, because again, this framework of a declarative SLO, SLI, and then is a different Captain SLI providers, we call them, can be hooked in, and we've got people building more. And again, here's my contact information. And again, I'm in the Meetup group, so you can direct message me through Meetup website, or you can reach me this way. And let's just see if I get lucky and have it finish. Come on, this would be the perfect demo if it works. Let's just see. Come on. It's not getting my answer real quick. But anyway, so I think I may be out of time here with our agenda, because I think I had exactly till 3:40. So is there any questions, I guess? I don't know if I have time for questions, but I'll stop there because that was my last slide without getting into more details.
Thank you, Rob. Everybody give him a round of applause. Click your reaction button. Next up, we have our next speaker, Paul Hammann, who's going to talk about reliability since the dawn of the internet.
So hi, my name is Paul Hammann, and I have been doing this for a while. I've been building reliable internet infrastructure since before the web existed, usually for early stage, high growth startups, 3 of which got bought by Microsoft. So I've been doing this for a while, and I like to think I've picked up a thing or two along the way. And in this talk, I'm going to talk about system design. You know, what does it mean to design a large system? What does it mean to design a reliable system? And the wonderful part of the SRE, which is large system design, which I always find extra fun. So back in 1987, Usenix had the first LISA conference. LISA stood for Large Installation System Administration. And to be considered large, you had to have at least 100 users or over 100 terabytes of storage. So the definition might have changed a little bit since then. What's large today? Pretty much anything you can point at. Obviously, places like Facebook, Google, Netflix, etc., are large. And I think now the better question is, or the better definition of large is complexity. Like if you need a sharded NoSQL database to make your service work, you probably count. So what are the goals of system design? We want to design something that's reliable, scalable, fast, and manageable. You know, and reliably, that's pretty obvious. Does it answer the queries? You know, does the data you store in it safe? Scalable, you know, will it grow to meet traffic? At speed, are you going to be able to answer queries quickly? Are you going to, and you know, if you have a large complex system where each query causes you to touch a dozen or more internal services, can you return quickly after that? And manageable. You know, it's going to break. So how long is it going to take you to know it's broken, to figure out why it's broken, to fix it? How safe is it to push new software? How easy is it to scale? So to do this, you know, for the rest of this talk, this is much more abstract than the original one. We're going to go through a few small system design exercises. And at the end, I'm going to tie it all together and talk about what's changed in system design over the last while, and you know, what hasn't changed. So the system design exercises we're going to do is a URL shortener like Bitly, an email server, and a file copier. So let's start with it. Let's start with the URL shortener. So what do we want it to do? Obviously, shorten URLs. How do you want to do it? Well, you want something that is highly available, therefore reliable. You don't lose the data. You want it to be, the data storage should be durable, and you want to do it quickly. So what does that tell us about our required bandwidth, stories, and queries per second? So we put some assumptions out there. You know, 500 million new URL shortenings per month. You know, you read it 100 times more than you write it. You want to store it for 5 years, etc. That will tell you a bit about how much you need to store it, how much bandwidth you need to serve it, how many queries per second you need to design for. So how do you build it? How do you build any multi-tier web application? You have clients that talk to application servers, that talk to a database. Database returns information to the application server, which returns it to which massages it and returns it to the client. So let's drill down in the database part of it. So what do we know about the data? We know there's a whole lot of very small records. We also know that there's there's no relation between the records. So what does that tell us about the database we need to, you know, what sort of database would allow us to serve things? Well, probably a NoSQL database. And there are any number of those that you can use. So how do we meet the requirements? We need to store a lot of non-relational records in a way that provides high availability, data integrity, and fast response time. A sharded NoSQL database would work in this instance. So, but we need to ask some more questions. You know, what kind of data do you shard on? Do you shard on the user ID or something else? What algorithm do you use for the sharding? How do you grow it? You know, if you want to add a you know, if you don't have insufficient shards and you need to expand your shard pool, how disruptive is that? So in the end, you're going to end up with something that looks like this. And in this example, we had kind of a blank slate. Problem statement, no restrictions, go crazy, build something. So let's move on to the next one, which is a much more constrained problem, a mail server. So in this problem, the problem statement is provide email accounts for 200,000 people. Sounds easy. And provide POP access and a terminal-based mail user agent. That's a little strange. So what's the story here? You have to use 1994 technology. You have to host it on a really old piece of hardware. You have to have a very small amount of storage. And to make things fun, you have to accept mail from BitNet and UCPNet. And yes, I did build this. So way back when I started figuring this out, we had to go with the assumptions. How much email were people getting a day? This was before spam. So, there wasn't you didn't get 100 emails a day. You got maybe one, actually, especially if you average it across the 200,000 users. Login frequency was not often, once a week for terminal users, once a day for POP clients. You got to remember, everybody was on dial-up. So you had to, your phone didn't work while you were online. So people would dial up, get their mail, hang up. Messages were small. Not a lot of images were sent. Your letter saying, hey, let's get together for potluck next week. It's under a kilobyte. So the functional requirements is the 200,000 users. The non-functional requirements are the restrictions. So we have most of the restrictions are technology. One of the problems was we're rolling Solaris 2.3 and it only had a 16-bit UID. So we could only get 65,000 users-ish on the system. The file system performance got horrible once we had only a few hundred users. And the file system gave us a full error when we had only 10% of the use space. So actually, we did solve all these problems before we actually launched, but it was a little fun finding them. So we needed a way to have more UIDs, and for an answer, we looked for directory services. There weren't a whole lot of them at the time. Solaris had something called Network Information Services, but it also had a 16-bit UID. These days, or even 20 years ago, you could use OpenLDAP, but it didn't come around until 1998. Thankfully, Solaris, our Sun, had just released Solaris NIS Plus, which had 32-bit UIDs. So that solved the problem. It just required us to rewrite nearly every piece of software we were using to provide the service. So that problem got solved. The file system performance got terrible, right? So what was the problem? Problem is Solaris used UFS, which is a version of the Berkeley Fast File System, and all the mail was stored in a single directory, one file per user. The problem with that is inodes are stored in a singly linked list in the directory structure. So every single time you read a file or wrote a file, you had to do a linear lookup. And with only a few hundred files, it made the system completely unusable. So now this is a similarity with the other one. How do we break up the data? We did a directory hash. So by having only a few, having 1,000 different directories, we managed to have 3,000 different directories. We only managed to have a dozen or so users in each directory. So we got much better file system performance. And the last problem, which is pretty obvious, we had a file system full. We didn't have nearly enough inodes for 200,000 tiny files. So that's an easy fix. All we had to do was reformat the disk. Well, now we have 200,000 users on this tiny system. How do we make sure they actually can use it? So we had to put user restrictions in place. Given the amount of email that got sent, the amount of time it got read, we had to have restrictions of 100 kilobyte quota, which sounds ridiculous these days, but everybody then thought it was perfectly reasonable. 20-minute maximum login time. If you're on the modem bank, because that's how everybody used it, for more than 20 minutes, you got kicked off. And you could only have 200 terminal users because they were actually logging on into a restricted shell on the server. Could only have 200 of those at the line. And mail was aged at 30 days. If anybody, so we had a process that walked through all the mailboxes, and any mail that was older than 30 days got deleted, which was a great way to prune the storage used. So the original one concrete problem. The last one was a problem from history. You know, it's an actual real system design problem that I had to solve in 1994. And the next one is kind of it's an abstract problem. You might come across this in a interview. These kind of questions, exercises tend to be more thought experiments than practical design. So, you know, if you were having this question in an interview, you'd get something that looked like this. You know, the interview question is, okay, design a system to copy a file to some computers. Well, if you need to copy a file to some computers, that sounds pretty easy. So what do you start doing? You go back and use the same process to estimate the data. So what do you need to know? Well, how big the file? Okay, it's 100 gigabytes, so that's a big file. How many machines? All right, there's 10,000 machines. That still doesn't sound too hard. How often? All right, once a day. Network, you know, what's the network topology? Where are the servers I need to copy this to? Well, they're all in another data center, and that data center is on the moon. This is a, you know, it's a system design interview question. They get really creative. So like, okay, I can work with that. What's the bandwidth link to the moon? 25 megabits per second. Can you give me any more information about you know, this radio length? Well, it's got 10% packet loss and 10% packet corruption. So I'm like, okay. So there are a few more assumptions. We only have one transmitter. The moon's only in the sky for half the day. So, you know, how long does it take to, you know, send 100 gigabytes over a 25 megabit per second link? 32,000 seconds. You know, there's around 43,000 seconds in half a day. So it's like, okay, so first order pass, I think it'll work, or I think it might work. So what are our assumptions? One transmitter, moon's only in the sky half the day, 43,000 second transmit window, 25 megabits per second link. Can we even do it? Is it possible? Well, with a 2600 millisecond round trip latency, TCP is totally unusable. So we'll have to use UDP. So UDP, obviously, there's no automatic retransmit. There's no, you know, it's all fire and forbid. Maybe that packet gets there, maybe it doesn't. Once it gets there, maybe it's corrupted, maybe it isn't. So what do? All right, let's break the file up into chunks. We break the file up into chunks. We can make this into instead of one big problem, a lot of smaller problems. So if I'm going to send a small packet there, how do I make sure it gets there? Well, and how do I make sure it's not corrupted? So Reed-Solomon is an error correction code that gets used on DVDs and all sorts of other places where you might find errors. And let's say, you know, and we'll estimate that it adds about 1% to the size of the file. And but it's not 100%. So even some of those files that show up are still going to, or some of those chunks that are going to be showing up are still going to be corrupted. So we can add a CRC check to each chunk. Okay, let's say that adds another 1%. Now we have a 102 gigabyte file. So we have to send, you know, thousands of chunks for 102 gigabytes, you know, through this radio link to the moon. So if we send, if we're sending this without, you know, without worrying about the overhead, it'll take, you know, it's still under 32,000 seconds. So if it's got a 20% retransmit rate, you know, roughly 10% packet loss, 10% corruption rate, you know, what do you get? So you have to resend 20% of those, of that 43,000, of that 32,000 seconds, right? And then you have to resend 20% of that. And then you have to resend 20% of that. And if you follow that all the way down the rabbit hole, it winnows down to only 40,802 seconds, which is less than 43,000 seconds. So yes, it is possible. So this is the sort of kind of abstract question that that you might get on an interview, which, it exercises like, can you think abstractly? Can you build a system given a small amount of information and know what the other information it is you need to get? So we've just done 3 examples. A Procrustean mail service, a kind of a standard, easy system design question. Design a URL shortener, and the data centers on the moon. So what's changed and what stays the same? So what has stayed the same is the design goals. When I was designing the mail service, it still needed to be reliable. It still needed to be scalable. Not very scalable, but if you look back at the directory hash, you would notice that the first hash was actually only 3 directories, because I was really hoping I was going to get budget to buy 219 gigabyte drives. You need to make it fast. In the case of the mail thing, is it fast enough? We had to serve 200,000 users, and fast in those days was a very different question, but it still was something you had to think about it, and manageable. Each one of these things you need to think about. How do you grow it? How do you manage it? So that's what stayed the same. And the characteristics. Every time we did an exercise, we had to estimate the capacity. Every time we did an exercise, we had to estimate the constraints. From the constraints of the tiny URL problem, which is, all right, we have to store a whole bunch of data quickly and redundantly. So how do we do that? A sharded NoSQL database. The constraints of the email system. It's like, all right, here's what you have to work with. Make it work. Reliable storage and data transmission. That was the big problem on the moon. It was actually also a big problem with mail services. Thankfully, backup MX records really helped there. And service bottlenecks. Once again, the moon example. Also, if you look at the solution to the system design problem for the tiny URL, you'll see a number of bottlenecks that you can move around. So what's different? Pretty much nothing. The technology's different. Obviously, it's the difference between the technology of today and 20 years ago, or even 10 years ago, is amazing, right? You can only problems that would require 1,000 servers to solve 10 years ago, you can do with 10 servers today. Problems that would take a huge amount of servers in 1995 could be done on 1 server today. The system design principles are the same. The characteristics of the exercises are the same. So that's more or less my talk. And we do have some resources for further study that I'd like to talk about a little bit. The site reliability handbook we got talked about earlier, and the companion to that, the site reliability workbook, is totally awesome. And the best thing I've ever read about system design is chapter 12, and you can get that free online. The next best thing I've ever seen on the internet, it isn't even an SRE resource. It's Design Principles for Ultra Large Scale Systems. It's put out by the International Council on Systems Engineering. It's actually, it's from a symposium they did in 2010. And if you go to their website, they want you to pay a huge amount of money for it. But if you just Google it online, you'll find a PDF. It's totally worth reading. High Scalability website is a great place to read about real systems that other people have built and the problems they came across and how they solved them. The tiny URL example came directly from a course called Grokking the System Design Interview put out by Educative. And I called them up yesterday and said, or emailed them yesterday and said, hey, I'm giving a talk tomorrow. Will you give me a discount code? So they gave me a discount code for for some courses there where it's SRE Meetup 20.
Thank you, everyone. And what I'll do now, since we're kind of at time, if people want to hang out and do some Q&A, we'll turn off the recording